Children, having understood what is the difference between linear equation and linear inequation, now we are very much aware what's the difference between linear equation and linear inequation. Let's proceed further with linear inequation and understand the basic rules of inequation. Right? In totality, there are 6 rules of inequation. But there are many who might be thinking that, sir, what they can see or what you people can see is only 4. So how many laws are there? 6 laws are there. The very first 2 laws are very much common and the same as that of linear equation. What I mean by saying is, the very first law is in an inequality, if minus sign number or number with minus sign, when goes on the other side of inequality, sign changes. If number with minus sign, when goes on the other side of inequality, sign changes. The same law applies with plus also. That means if a number with positive sign goes on the other side of inequality, sign changes. That's what we used to do in equation also. So these 2 laws are absolutely, the very first 2 laws are absolutely the same as that of linear inequation. So we cut short our 6 laws into 4 laws, which I have termed as rule 1, rule 2, rule 3, rule 4. So let's start with the basic 4 rules of linear inequation. Right? Let's start. Rule 1. Now what is rule 1 trying to say? Let's understand it. If each term of an inequation be multiplied or divided by the same positive number, mind you, positive number, the sign of inequality remains the same. That means if we have an inequality, we multiply that inequality with a same positive number, the sign of inequality remains the same. Even if we divide by same positive number, sign of inequality remains the same. To understand our example, let's take, to understand this one, let's take an example. But prior to that, what exactly the rule wants to say? The rule says if x is greater than y, then mx is greater than my. Now what is m? M is any multiple, positive multiple. M is any positive multiple. So let's understand this first. So example, say children, 5 greater than 3. Say 5 greater than 3. We are aware that 5 is greater than 3. Let then m be 2. We have to have a same positive number which is getting multiplied. So here we say let m is equals to 2. That means mx. So when I say m is 2, how much is it? 5 into 2, 10. 3 into 2, 6. Now check it out. 10 is greater than 6. Right? So if x greater than y, then mx greater than my. That is 5 greater than 3. Let m be the common multiple. Same positive number, mind you. Same positive number. Let that number be 2. Then 5 into 2 is greater than 3 into 2. Now this was for multiplication. Let's go and understand division also. Also, if x greater than y, then this time it's division. I can say x by m is greater than y by m. This time we are dividing it by the same positive number. So let's take an example. Example, 10 greater than 8. Is it? Yes. Let m be 2. Once again, m is a common divisor, same positive number. So 10 by 2 is always greater than 8 by 2. How much is 10 by 2? 5. Greater than 4. Right, children? Very simple. First rule is very, very simple. So we once again say, if each term of an inequation be multiplied or divided by the same positive number, the sign of inequality remains the same. Right? Let's move on to rule number 2. Quite important rule. If each term of an inequation be multiplied or divided by the same negative Here it was positive. Here it is negative. Number, the sign of inequality reverses. Kindly keep this in mind. When you multiply an inequation with a negative number, when you multiply an inequation with a negative number, though any number it may be, but it should be multiplied to, that particular number should be same throughout, sign of inequality changes. So let's understand. If x is greater than y, then minus mx minus my. Now where the sign is, x is greater than y, but here my multiple being a negative, sign of inequality changes. Minus mx is less than minus my. Let's understand by an example. So again we shall say same example. Example, 5 greater than 3 children. We are aware. Let this time m not be a positive, it has to be a negative. So let m be minus 2. Now when we multiply 5 with minus 2, what we get? We get minus 10. When we multiply 3 with minus 2, what we get? We get minus 6. Now children, it is you who are going to decide which is greater, minus 6 or minus 10. For negative integers, we have exactly opposite rule. Minus 6 is greater. Minus 10 is smaller. Sign of inequality changes. Sign of inequality changes, as I mentioned earlier. Right? The same law applies when we go for a division also. If x greater than y, then x upon minus m is less than y upon minus m. Are you getting me? If x greater than y, x upon minus m is less than y upon minus m. Again, m being a common multiple or same negative number. Let's check it out. Example, minus, or let me say x greater than y. So here it is 10 greater than 8. We are taking the same example, children. But this time, let m is equals to minus 2. So what is 10 upon minus 2? And what is 8 upon minus 2? 10 upon minus 2 is minus 5. 8 upon minus 2 is minus 4. Now you decide who is greater, but natural. So sign of inequality changes. Sign of inequality changes. Right? Once again, rule 2, most important one. If each term of an inequation be multiplied or divided by same negative number, the sign of inequality reverses. Kindly keep this in mind. Most of the children go wrong in this. In haste, they don't apply this rule. They go wrong. Right? Let's proceed further with rule number 3. Now rule number 3, you can say, has been derived from rule number 2 only. But though this rule has its own existence, but more or less you can say it is being derived from rule number 2 only. Let's see what is rule number 3 trying to say. If sign of each term on both the sides of inequation is changed, if sign of each term on both the sides of inequation is changed, the sign of inequality gets reversed. So those who are not understanding, here we go. Let's take, or rather make us understand, if x is greater than y. What is the law trying to make us understand? What is the rule trying to make us understand? If each term, if the sign on each term of both the sides of inequality is changed, that means we are going to change the sign. As of now, what are these two? Both of them are positive. Both of them are positive. Right? Then if I change this sign, if I change their sign, that means, what am I doing? I'm just multiplying by minus 1. I'm just multiplying with by minus 1. Because if in order to change any number's sign, we just have to multiply it by minus, if the number is positive. So when I multiply this by minus 1, so will I get minus x? When I multiply this by minus 1, will I get this by minus y? As we studied in rule 2, whenever we multiply with same negative number, sign of inequality changes. This is what rule number 3 tries to say. This is what rule number 3 tries to say. Are you getting me? Now, you might be thinking that, what if both are negative? Again, same thing. Both are negative. When you multiply with minus 1, both shall be positive. But let's see this example. Example, 5 greater than 3 when you multiply with minus sign, minus 5 is less than minus 3. Let's take one more example where I say both the numbers are negative. So minus 5 and minus 3. Now we know that minus 5 is greater than minus 3. This is example number 2. Not from here. This is a separate example. Now if I change the sign on either side of inequality, that means again I'm multiplying with minus 1. Right? When I multiply this by minus 1, what will happen? 5. Here 3. But natural sign of inequality changes. That's what the rule tries to say. It reverses, means it is getting changed. Here it was here. Sir, what if one is positive, one is negative? Again, no problem. So third example. Minus 5, 3. Come on, can I say this? Now I'm changing the sign as rule number 3 says. So when I say changing the sign means multiplying by minus 1. So when I multiply this by minus 1, will this be 5? Will this be minus 3? Who is greater? As simple. Or for that matter, the last one, if 3 is greater than minus 5, multiply by minus 1. Everywhere you can see, when you change the sign of inequality on both the sides, the sign of inequality reverses or gets changed, reverse direction. Right, children? Last, again very important. If both the sides of the inequation are positive or negative, this is very important. Very, very important that both should be either positive or both should be either negative. You cannot claim one positive, one negative. Mind you, for rule number 4, both should be positive or both should be negative. You cannot claim one positive, one negative. No, children. So, once again, if both the sides of an equation are positive or negative, then on taking their reciprocals, the sign of inequality changes. On taking their reciprocals, the sign of inequality changes. So let's understand. If x is greater than y, then on taking their reciprocals, 1 by x, 1 by y, law says sign of inequality changes. Let's take an example. Example. Children, 5 greater than 4, as we know. Then reciprocal 1 by 5, 1 by 4. Now I have not put or inserted any sign. Let's calculate what is 1 by 5. Children, 1 by 5 is 0.20. 1 by 5 is 0.20. 1 by 4 is 0.25. 1 by 4 is 0.25. Now you decide which is greater. 0.25 is greater or 0.20 is greater. But natural 0.25. 0.25 is nothing but 1 by 4. So, when we are being given an inequality, both positive, if their reciprocals are taken, sign changes. Sir, what if both negative? No problem. Again, let's take example. Minus 5, minus 4. But here can I say it's like this? So, this is our second example. Minus 5 is less than minus 4. Now, I would like to take their reciprocals. 1 by minus 5, 1 by minus 4. We all know that the sign in the denominator moves in the numerator. So, minus. Here also minus. Now, again, 1 by 5 is minus. That is minus 1 by 5 is minus 0.20. So, let me write down. So, for your better understanding, let me write down this. Minus 0.20 and minus 0.25. Minus 0.25. Now, you decide which one is greater. But naturally, you shall say this one is greater. Minus 0.20 is greater. Sign of inequality changes. But sir, if you say one positive, one negative on the inequality side, no, the rule doesn't apply. Both the numbers either positive or negative. On their reciprocals, sign of inequality gets reversed or gets changed. Children, these are prima facie 4 basic laws. If you remember this, apply in a right direction, linear inequation is very, very simple. At times, students fail to apply the law in the sum, go wrong. Right? That's it.